Assalamu alaikum sir, this is Syed Shafin Ahmed. My student ID is 222156151 and the topic of my presentation is Generative Adversarial Network. So let's begin. What is GAN? GAN stands for Generative Adversarial Network, which is a type of deep learning model where two neural networks, a generator and a discriminator, compete in a game theoretic framework to produce data that mimics real-world data. Introduced by Ian Goodfellow in 2014, GANs are widely used for data generation and augmentation tasks. Here is the GAN architecture. The component generator takes random noises as input and generates synthetic data. On the other hand, component discriminator classifies inputs as real or fake from generators. Training is adversarial. Generator tries to fool the discriminator. Discriminator learns to catch the generator's fakes. And here we have the min-max laws. GANs follow a minimax optimization where the generator and discriminator are adversaries. Moving on. Here is the example of GAN. MNIST digit generation. Real data was 28 into 28 grayscale handwritten digits. Generator input was random noise vector, which we're gonna call a C. Generator output fake digit image. Discriminator input was image. It could be real or fake. Discriminator output was probability score. And the goal was to generate produces realistic digits that discriminator cannot distinguish from the real ones. Moving on. Here are the applications of GAN. The first one is image synthesis. Examples are face generation, super resolution. Data augmentation. Examples are medical data and imbalanced data sets. The next one is game content generation, anomaly detection, text to image generation, and finally privacy preserving data sharing. Moving on, here is the comparison of GAN and other generative models. GAN, on the other hand, GAN is a high data generation quality. On the other hand, the variational autoencoders are moderate data generation quality, and autoregressive models are similar to GAN. The training stability of GAN is difficult than that of variational autoencoders, and autoregressive models are easier. Latent space structures are unstructured in terms of GAN and structured in terms of variational autoencoders. It is not applicable for autoregressive models. The mode collapse risks are high in terms of GAN. On the other hand, it is very low, and it can be said that there are really no collapse risks at variational autoencoders and autoregressive models. And GAN and variational autoencoders allow parallel generation. On the other hand, autoregressive models does not allow parallel generation. That's all from me. Thank you, sir. Assalamu alaikum.